This problem is but. We are given an angle theta in standard position as shown in the figure below. So here's my figure. It's a nice, it's spun around, lives somewhere in the fourth quadrant, yippee-i-o. The function g is defined by g of a equals sine a. So we'll deal with that in a minute. For an angle alpha, which is me, not shown, alpha is in between theta and 2 pi. So there's some angle in between here, right? That's also spun around that lives right there. Which of the following is true? So we have, you plug in alpha, you get some information, and then we'll see what happens. So let's see what they're trying to ask, all right? You're going to plug in some point. You're going to plug in some point, and you're going to use the sine function to get something. Now, the sine function is going to be a y value. So when you look at these 2 points, you have this point which has to do with theta, you have this point which has to do with alpha. You're looking at these 2 points, which means what you get, the y value, is going to be g of theta here for this one, this black dot right here, and this red dot, the y value, is going to be g of alpha. What happens here is if we're looking at y values again, no matter where I put this dot, and let's see if it'll let me move it. Will it? No, it won't. Let me see if it'll, here, let me try this button. There we are. All right. So what this is basically saying, okay, is I could put a g of alpha anywhere between u and u, but no matter where I put it, it's going to be above g of theta. So in this case, no matter what happens, since sine is y, g of alpha is going to be higher than g of theta, which means g of alpha is going to be greater than g of theta. So a very bizarre problem. Not a huge fan of it, but these problems do show up like on AP Precalculus Practice Tests. So that's why I put it here. So hope my description helped a little bit.